people to be here to talk about project planning and to give opinions on what the project ought to be. Because if somebody really wants to do something for the project, we can probably accommodate that. It's a special topics course. There's nothing that follows onto it or anything. And so if somebody's like, well, I always wanted to build this graphical world with growing grass in it that the geometry shaders will produce. And there's going to be giraffes, and they're going to eat the grass when they're on the trees. And that will lower down the grass, and then the geometry shaders will slowly rebuild the grass.
That sounds like something Jesse would make.
Yeah, kind of maybe. Anyway, so if somebody had something that they wanted to do, then we could just make a project for that person. Everybody can do a different project too. The way I have to grade them is just, does this fulfill the initial specifications for the project, or something kind of equivalent if it turns out that the original specification was somewhat fanciful. This happens sometimes. But yeah, that could definitely be done. I still haven't quite worked out the details. I want to have it free form enough that everybody can do what they're really interested in, but yet somehow make it so that the project specifications enforce that you actually learn how to program a GPU. And it's a little bit hard to just say that in the project description. That's why I'm still working it out.
That is a little bit broad.
Yeah, it is. Yeah, but that's what project descriptions do. They take some broad principle. You should all learn how to program computers. And they try to distill it into a set of project requirements. For the early classes, like 108 or whatever, you have to follow the requirements quite exactly. But the higher level the class is, and the more the class is just kind of a one-off nature, the more that gets to be a little bit flexible as long as the broader goal is accomplished. So,
and we get some very esoteric, weird things.
Right. And graduate school is even more that way. In graduate school, the basic requirement of the class is that you learn something. And in some of the classes, it's not even that well defined what exactly it is that you might happen to learn. So, kind of thinking of a class on optimization and making things work better. And so we kind of had our own little projects. Nobody quite did the same thing, and that was fun. Anyway, so I'll come up with some sort of minimum specification for the project. But if you got some sort of idea, definitely think about it. And if you don't have an idea yet, that'd be a good thing to work on, having one. And if you don't have an idea, I'll have actual ideas eventually here. I'll try to get a kind of a template for the project together, maybe next week, and I might have decide what you're actually going to do as an initial goal, or it might have some projects that one can just take and run with. I think I'll put at least a couple of those, because there's always somebody who's like, oh, well, I don't really feel like being creative. Why don't you just tell me a project to do, and I'll do it, and then I will learn how to program shaders. That's perfect.
I mean, I like having suggestions to work off of, because coming up with original projects is something that makes my brain hurt some days.
Right. I mostly put this up here to see if anybody's like, oh, well, I really have this thing I want to do.
I'm sure Jesse probably does.
Can't think of anything right now.
Okay.
I'll probably know more when you hammer out the details of what we need to do.
Sure. Yeah. I'll get together details, and then ideas will appear.
Particle simulation.
Okay, so last time lab was harder than it has been in the past. I know this because I didn't actually check off what most people have done yet. So it must have been harder.
Well, that scares me.
Well,
Not yet. I was sick. I've been sick for like a week.
You should start.
Well, I'm gonna get to it.
it also might be that I didn't instruct the lab quite as well, being rather sick myself. I was feeling like I was all better yesterday, and after teaching classes, I was definitely not better. Today, I woke up feeling like I was definitely better, and so we'll see how I am in an hour.
I woke up today feeling much better than I had been. That's why I'm so much more talkative and attentive right now than I have been.
I Googled all the various little folk remedies because I was curious which ones work and don't work, and if any of them work, because it would be nice if some of them work. And the main one I could find out with scientific evidence behind it was the vitamin C. And it doesn't appear to stop people from getting sick, at least in controlled studies. It does if you just ask my mother-in-law. But it apparently does actually shorten the duration of illness. And it may shorten it disproportionately depending on how athletically active you are. As in, if you're more athletically active, it may shorten it by a greater percentage. Anyway, not something that'll affect most people in CS.
We're very athletic. We're on the top three.
Well, yeah, I think our main athletic skill is like sitting in chairs for long periods of time. There's always exceptions. I have people that do bring me little sports forms, like I am going to be off, doing this thing, jumping over high barriers. Some days.
But much more common is things like what Alex did.
Oh yes, yes. Okay, so geometry shaders. I want to talk about these and give kind of more examples, and I think this will help make the lab make more sense, even for everybody that's already done it, and open up a little bit more possibilities for what you can do with these things. So, we have this tree thing, this bush example, and I'll go ahead and bring it back in here. Let's do this. I always bring it over to /tmp, and I use /tmp quite a lot. It used to be that you would make temporary directories that were intended to be temporary, and I never really remember if they were temporary or not. So I'd have all these directories named T and temp1 and that kind of thing, filled with various random contents that might or might not have been permanent residents. And so I decided that instead of that, I was going to start using the /tmp directory, which is intended for temporary files, to put things that I didn't intend to preserve forever, because that directory contents go away when you restart the computer. And so now when I download somebody's assignment to look at it and give an opinion on it, I always put it in /tmp. Then it gets cleared out. It's nice. I don't have all these files from years ago. But I kept putting the examples there, and of course this computer, instead of being rebooted every, I don't know what Nimrod is going on, like 6 months or something, this one's rebooted like twice a day. And so /tmp is much more ephemeral. Incidentally, speaking of ephemeral things, Alex Bezridis over in the office over there is looking for an ephemeroptera, an adult mayfly, and they only live about 8 hours. So if you see one on your way in, just stuff it under his door. Okay.
I saw somebody kill a fly right here earlier.
Yeah, that was probably a fly.
Yeah, if it's a housefly, that's the wrong type. Mayfly is the right type.
I don't know what it was. I just saw some kind of bug.
Incidentally, when I make like a virtual machine operating system installation, it's only going to persist for about a week. I almost always name the system ephemeroptera. Okay, so the bush thing. So we've been playing with this silly tree thing for a while, and that's why I made the silly tree thing, so we can play with it for a while. And it can be made shorter. Currently, we've been running it with 10 levels, I think, right there. And so if you set it to like 3 levels, then it's shorter. Okay, now we got short little trees. Well, they didn't branch very many times.
Don't forget to adjust the screen size for the camera.
Oh yeah. And if you do it 20, then it's taller and more bushy. And now we can't see it. But if I do that, we still can't see it. Okay. Well, anyway, so you can make the tree bigger, and if you make it big enough, eventually there will be some number that slows down any graphics card, no matter how powerful. Okay.
3,000.
I'm sure that would do it. That actually might make the program take a significant amount of time before it appears, since that would be 2 to the 3,000 possible vertices.
Woohoo!
And it increases exponentially. It doubles at each level.
Mm-hmm.
Okay, so you can see we got these trees, and the branches get shorter as we go. That's good. I forgot we did that. We were going to add that today to increase realism, but apparently it already does that, so no big deal there. Okay, so then you eventually end up with terminal branches at the very end. So, using a geometry shader, we should be able to add fruit to the tree. There's trees, like most of the ones on campus here, that produce like leaves and flowers, which is good, useful food if you're a goat. But most people that like to eat food from trees prefer fruiting trees that grow like peaches or blueberries or pecans or something like that.
I want to see a tree that produces blueberries, considering blueberries grow off of a bush.
Bush, yeah. Well, yeah, I suppose it's that. But you know, if you look at this thing here, it looks a little bit more blueberry bush-like than like a pecan tree.
Mm-hmm.
Anyway, so you get fruit off of trees, like nuts and whatnot. So we'll have some fruit to this tree. Okay, so when we do this, there's one other thing we need to add to this. Okay, one of the reasons this looks a little bit unnatural. This one first, we'll add fruit. It's got these lines, and the lines don't have any thickness to them whatsoever. When you say a GL lines, it draws a line as intended, but it just draws it 1 pixel thick, and so it's a very fine line. Trees, on the other hand, have a thicker branch that comes out of the ground. Not everybody calls it a branch. Some people call it a trunk. Anyway, so it comes out of the ground and it's thicker, and they get thinner as they go. And I realize when you think of a tree, you probably think of something like, and you're like, wait a minute, these branches are all exactly the same thickness. And yeah, I mean, that's how a tree is in CS. It's the same. Not real trees. Okay, so take a look at this geometry shader. G.glsl. Right now it's outputting a line strip. And so we're taking the current lines and copying them in a couple of different places. So I'm going to go ahead and gut this thing. I'll take off the little copy thingies. And this part here can stay, but we only want one invocation for right now. And we'll change it so it outputs triangle. Okay, max vertices will have to be somewhat higher. I'll set that later to something else. If we leave the question mark, it'll give us a compile error, and then we'll have to go figure it out. Okay, so from this, we should be able to make a branch. So if we have a branch function up here, let's make this a function. Branch. Okay, so I can take a start point and an end point. Those are both vectors. And then we'll have a thickness for the branch. And that can be a float. Okay. So that's our branch function parameters. And so now we're just going to make a branch out of triangles. So we can actually make a 3D object here instead of just having OpenGL draw us a line. And so if we draw a 3D object for a branch, it can be whatever shape we like. In fact, we might end up liking to make them not perfectly straight because you don't really see a perfectly straight one all that often. If you look at, say, an alder grove, if you look long enough, you'll find some good straight poles. For example, if you wanted to make spears and throw them at your friends. But a lot of other trees are just not that straight, like ever. If you look at an apple tree and try and find a straight stick on the thing, it might have some brand new growth sticks that are pretty straight right at the top, but in general, it's not going to have a lot of straight wood on it. Branch. I want to have a class someday, CS92, 492, generating foliage. It'll be fun. We'll cross-list it with biology.
I love all of these random 492 ideas you come up with and spout out through these classes.
But this is kind of a random.
Didn't you want to cross it with forestry or ecology?
Yeah, I'm assuming those are under the biology banner.
Maybe.
Biology also has a flexible program of the sort that we're going to strive to emulate, where you can actually take any 300 or 400 level class you want and apply it to your biology degree as the effort division part. So it makes it very easy if you wanted to specialize somehow. If you're like, okay, I'm going to do biochem or biophysics or something like that, you don't even ask anybody. You just take the right classes to make that happen. So here, if you're like, I want a hybrid between computer science and art, and then I'm going to go work on automatic rendering of models in the game industry. You have to talk to your advisor and have them do all sorts of weird paperwork that they don't know how to do. And it's fine. I mean, that's what we're here for. But it would be nicer if you could just take the classes and make it happen. Okay, so the branch has two ends, and we might set up the center in some nicer way if we have a moment. There's a thing called Perlin noise, where you adjust the branch kind of in an iterative recursive process to make everything happen right. But take the end of a branch. So branches can be different shapes. A really simple branch is a triangle. These are pretty simple because they only require a few panels on the side, and that might really be pretty good. So we only need six per branch. Now, it would be nice to be able to do more than just 3, and so that should maybe be a parameter. We don't set that just yet. 3 is enough to look okay, and 3 is like the minimum number that looks okay. Otherwise, it looks like you got the tree made out of tapeworms if you just pick a couple, like 2 sides. You don't need 2 sides. You can have one side in that case, like one triangle as it goes. So I suppose you could do two that are separated by a gap, and then you can see through the branch at certain angles. But I think that also would look weird. You could probably do the two as a plus sign. You do that. That could look okay. Anyway, actually that might be the minimum. I bet so that's it. Okay. Let's say that's it. We'll go ahead and do the plus sign approach. Be smaller. I'll draw this stuff lightweight. Okay. So there we go. So it's got a start point and an end point, and then we need to be able to go out just a little bit from it. So the corners of these things, we'll have, we only need 4 triangles now, maybe this even better. And so as we take the start, so we want to do 4 vertices. Okay, so panel 1, the first flat one. Now, we got a decision to make here regarding axes and where exactly we go. So it's possible to take these, and we'll probably just do this, and align each of our panels with some sort of axis. And since this is intended to simulate something round, that's fine. But if we wanted to, we could take these and try to orient them in some way, like, it's 45 degrees from the ground or something like that. I don't think there's a lot of benefit to doing that. I think it'd be a lot of calculations that don't really help much of anything. Could be done. Okay, so we did the start, and we added the vector. Say we stretched along the x-axis and then the z-axis, assuming these things are going to go more or less up. So we can take the thickness and 0, 0, 0, and add the start, and end up with position 1. Okay. So if we're going to draw a triangle here, you can draw a triangle. Suppose this is the side of the branch that we're drawing. So you got these 4 vertices. Let's say they're A, B, C, D. Okay, so if we draw them this way, we're actually fine. We draw A, B, and C, you get that triangle. Oh, no, we're not fine. We can't draw in this order at all. We have to draw like A. If we draw A, B, C, then we're stuck. If we draw B, A, C, then it puts that triangle in. Then when we draw D, it fills the whole thing in. Because of the whole triangle fan nature. I've been talking to a few folks about this, triangle script, excuse me, not fan, about this at the end of the lab. We were getting this thing right. A few people ended up with funny issues going on. So if you see A, B, C there, A is the one that's not part of triangle 2. So you got to start with the point that's not part of both, and then end with the other one that's not part of both. Okay. Yeah, if you haven't done the lab yet, remember that. Okay. Or you can just draw 2 separate triangles, because you can actually do 3 of these, then hit end primitive, then do the other 3. It results in specifying 6 vertices instead of 4. But it might not actually affect things later. I guess it's sort of up to the driver implementation whether or not it does affect things later. But suppose somebody had carefully specified this only using the 4 vertices in triangle strip in the vertex shader. And so the vertex shader only processed 4 instead of 6. Great. But it's actually going to feed 2 primitives comprising 6 vertices to our geometry shader. So at some point it actually goes into individual triangles in the pipeline.
When does that happen?
Before it gets to the geometry shader. And so I'm thinking that the geometry shader probably gets re-triangulized into individual ones before it hits rasterization.
Did you say there was a tessellation shader?
Yeah, that would be between the vertex and geometry shader if we had it.
It seems like that would be the perfect thing for tessellation shader.
Yeah, that would be a good thing for it to do. But it's going to happen again after the geometry shader, since the geometry shader will be output a triangle strip. And in fact, we're required to. We can't output individual primitives unless we call end primitive and force the whole thing. Okay, so there's one, had start plus the thickness, so then we can emit vertex. Okay, now the color here. We've had this F color that's been getting passed on the whole time. Equals FCA at position. Okay, so now we got 2 ends of this whole FCA thing. Now I'm pretty sure that the way we set up our vertex shader, they're always exactly the same. So I'm going to just go ahead and grab position 1 on it. Okay. So these 3 lines together emit 1. I don't think we're allowed to have a nested function in here. So we'll just go ahead and make an easy way to do that. Okay. I'll call this function emit, simple. And it takes a vec for position. And what it does, just the stuff we just did. GL position equals position. F color equals FCA. And emit vertex. Okay. So now all we have to do down here is to say emit simple. Okay. So start plus the vertex there. Let's go ahead and get our 4. So then we start minus that vector. Okay. So now if we take the end point, so the start point is like here. The end point is like here. So we went plus, and then we went minus. So we did one of those, and we did the other one. So we should do the minus point again here for the next one. Keeping going around here in the right order. And then the end plus point. Is that right? No, that's not right. Because that does that, and then the second one will draw like a weird triangle over here. We'll actually be left with an empty space right there. So no, it's not right. If we go minus, plus, minus, we want to go back across in order to get this right. So we want to do a zigzag pattern. Okay. Because ultimately what we have to draw here is a zigzag. Like if we do this, then it'll end up right. You take those two triangles and fill them in, and you got the right figure. So you want a zigzag. Okay, so after that, we can end primitive. And we want to do the same thing for the other panel. Okay, so this one, instead of going in the x-axis, we'll go in the y. Now, we can continue our theme here of putting this in small things and not cutting and pasting. If we say emit panel, okay, and then we'll take start for end, and then the thing that we're adding on to it, addition. That's also back for it. Then all we have to do is take one of these things, put it up here, and so instead of thickness, we'll be using addition. Okay. The Hawkeye among you will notice that I have, in fact, switched this one, this float here, to that instead of thickness, but no big deal. Oh, we also didn't take out all this extra stuff. Okay, the cut and paste there actually didn't really help us very much. Okay. There we go. So now we got our addition there. So down here, we just have to say emit panel, and this should have the start and the end, and then a vec4. So for the first one, it'll be thickness 0, 0, 0. For the second one, thickness will be in the Z plane. Okay. So that should emit those two primitives when we do branch. So for invocation ID 0, we don't actually need to say that. We can emit later. Sorry. So I say branch. And so we've got a thickness here. If we relate the thickness to the length, it'll be somewhat biologically sensitive, since normally the branches do have a thickness that's kind of proportional to length, certain aspect ratio. Now, it's not all, there's some branches that have a different aspect ratio than others. But in general, if you have a really long branch, you expect it to be thicker, and if you have a really skinny branch, you wouldn't expect it to be all that long, right? Everybody's wondering if they've seen a tree before, or everybody's asleep. Or they get it. Okay. So we can take a branch and draw it from the start. That would be the in. GLN, I think it's GLN, at position 0, dot GL position, and then we have the stop. capital P over here. Okay, and then we have the thickness. So if we make the thickness proportional to the distance, we can get the distance easy enough. Or we could automatically have it do that. That could be quite good. Just automatically calculate it. Instead of taking it right here, just figure it out. Okay. So distance from the start to the end. And we want to divide it by something. We don't want to branch this as fat as it is long. That'll look weird. Maybe 10. Something like that. Okay. So that should draw branches. Okay, and how many max vertices? So we're putting out 4 per panel. We're drawing a branch in 2 panels. So 8. Okay, see what happens. Okay. I think it's triangle strip, not triangles strip.
I think we make that mistake a lot.
Couldn't have find uniform MVP. I didn't say anything about MVP here. We say that in the vertex shader, don't we? Use a V. It's a uniform match for MVP. And we use it right there, vertex shader. So why is that not okay? Remake it. Doesn't be remade. Oh, we did say it up here. No, that's the vertex shader. Didn't say anything about it. Okay, so I'm not sure why I can't find the MVP. Suppose we say we want it here. That'll probably cause a problem. Find it for MVP. So now I'm not sure how we close this. Because that still looks fine there. And we didn't change anything in there. We left that one all alone. Okay, now I'm puzzled. There was no reason that should actually work. Okay, so it seems to be intent on throwing this. Couldn't find a uniform MVP. The only thing we actually changed was our geometry shader. And so it seems like, logically speaking, it sort of has to come from there. We'll go ahead and copy this to a home directory and try bringing in a different one. And now everything's happy. So this one is fine.
But it doesn't use MVP.
Yeah. So logically, we can say that there is something here that's causing the problem, since when we make this change, now we have a problem, and before that, we did not have a problem. So we make this kind of a pass-through geometry shader. We can do that. Let's say we do lines. Okay, let's just try lines at first and see what happens here. Line strip, I think that's what they call it. Okay, it doesn't seem to have anything to do with that. Let's try. So it couldn't bind it, so that means it couldn't load it. So if we comment out the bulk of this thing here, then we should be able to get to the end of it. We say, we're checking GL invocation ID right here. We can't say branch anymore if we didn't define the function, but we can say something like GL position equals, and then I'll just go for GL in at position 0. GL position. Okay. You know, I just saw something.
Huh.
So let's take that out. There's an init vertex here that doesn't have the parentheses. Let's check that. I don't see any good reason for that to have caused the particular error that we received.
But
obviously that was it.
Oh, that's weird.
So here's probably what happened there. The cube has the air handling stuff is kind of a little bit weird on here. So it's got these things like MVP, and we go ahead and check and see, could a GL get uniform location from this program? Well, the program probably failed to compile. For some reason, we made it past that STD error and that linked OK up there. Not sure why that happened, but we made it past there and didn't actually return 0 and print out this error. And so since we made it past, it failed later.
Interesting.
Yeah. Okay. Well, anyway, so we got our thick branches there. I'm not sure if the tree particularly looks better because they don't have rounded ends.
I also find it a little strange how that one branch down there is super thin and then has big thick branches coming out of it.
They're longer than it is.
It looks like a cactus, I guess.
It kind of does.
Does it show up different each time?
No.
Interesting.
Some cactuses bear fruit, I guess.
If it was seeded differently, it would show up different each time. Okay. Well, anyway, we'll leave it for the moment. Might add one more level to it. Might look better. I don't know if it will actually look any better with another level. Or go for 2 more levels. There we go. Okay. So now that we've got our tree that I actually think looks uglier, we can go ahead and add to it. Okay. I teach CS 101 labs sometimes, and we do things where we do like rendering and artistic stuff because I really like the generated graphics, especially for the 108. It really shows you what you've done wrong if you're like, I thought that it was going to make a circle. And actually, it just started covering the whole screen in diagonal lines. It's good feedback, good visual feedback. But half the time, students have something that looks really, really cool, but it's like totally not what was intended. And they're like, why is it doing this weird, cool looking thing? And I'm like, oh, just change that number to be the same as that number. And then it'll look boring like the assignment was supposed to look. Okay, so let's go ahead and add proof. Okay, so this GL invocations thing is a way to do this. I was reading an article just before class this morning on why geometry shaders are bad. And it's always good to read articles on why things are bad, even if it's something you really like that you don't agree with, that it's bad, because you'll see opinions on what somebody could do with it that makes it quite wrong. And so the article's point was basically, in some cases, using a geometry shader can be slow. And of course, the entire point of 3D acceleration is to be fast. And so if you make a lengthy geometry shader that takes a primitive and then does a whole bunch of work on just a few primitives, then it really disrupts the whole multi-threaded nature. Now, if you're like, well, I can define a character by a single point, and then I can have the geometry shader take that one point and generate the entire character from it, then you've got a really long process that only happens on a few shaders at once. So the entire thing on a video card is intended to have a whole bunch of short and simple processes. So replacing that with a few complicated ones is a very CPU kind of model. And so we really want to avoid doing that in the geometry shader. So the article that I read, I think it was actually old, because in OpenGL 4, I think it was 4, they added this invocations thing where you can have more than one invocation happening, which just gives you an invocation ID right down here. And so we can say if the invocation is 0, we do this. Else if GL invocation ID is 1, then we'll do the fruit variety. Okay, and so that allows us to have more smaller processes. Again, trying to work with the video card instead of against it. It seemed like the article author, they had a few ways he'd done this test, and in some ways using a geometry shader was way slower than if you did twice as much math on the vertex shaders because of this kind of problem. Anyway, so that kind of problem can be avoided if you carefully make sure you got plenty of invocations. The other point that he had, which we're not helping really very much with this example, is when you say, suppose you have your geometry shaders and you output a whole bunch of primitives. Then next, those primitives are going to have to be rasterized. So we're going to have a, this geometry shader step, then the next step. And so between those two, they all got to go somewhere. When you're doing everything with the vertex shaders have a one-to-one mapping. They take one vertex and they move it around to the right spot where it's supposed to go. They might also adjust associated data with that vertex. But if you imagine like one array, then they can populate another array with the exact same amount of stuff, you see? Each position just runs straight across parallel. It's like the boards on a deck. The geometry shader disrupts that. Because when you got a geometry shader, you take everything as primitives, and then you can output 0 to n primitives from the geometry shader. So now we don't have this deck nature where you got straight boards that go from one place to the next. You got a board that ends, and then you might have 0 to n more boards coming out of it. So it disrupts the whole parallel flow just a little bit. Anyway, so we're not helping out at all here. All of the primitives that we generate from this vertex shader are going to have to be cached somewhere before they can be rasterized as the next step. And so if you decided to generate some really complicated vertex data, really complicated geometry in a geometry shader, and doesn't fit in video memory, then it's going to go into CPU memory, and then everything's going to go badly with frame rate. And even if you are just using up a bunch of GPU memory, you got to remember the stuff that's generated in these geometry shaders does have to be squirreled away and then rasterized, and so it's going to take up GPU memory, which is much more valuable than CPU memory. Yeah, well, we got like 6 and 128. Yeah. Okay, well anyway, all that aside, we should have fruit. So, it has to have a function that makes fruit. Okay, so when we have the fruit, it could be like a cube or this could just be a triangle thing actually, 4 triangles. It could be a variety of different shapes, but it's got to be some shape. And it might be nice if we have a level of detail, but I don't think we're going to put that in right at this moment. So we'll have some point that is at vec4 spot. Okay, and it might be nice if we had an adjustable size. Okay, so we can have different sizes of fruit. Real trees grow different sizes of fruit. That's not my trees. Okay, I'm not really, but I am right now. Okay, so once we get this spot, we just have to make a triangular prism out of it. So if you take a triangle, this isn't like impossible. Okay, so pens maybe. All the pens are the same length. That's good, but they don't stick together very well. That's not as good. Okay, and I only have 2 hands and not like 7 hands. That's also not very good for this modeling. Need some molecular models. Jesse was using styrofoam and sticks and stabbing and stuff. Anyway, so you can see what I'm trying to put together here, right? If I take 2 of these and put them like this, then we can get all but one rendered in the right spot. There you go. Something where we got like a triangle thing like this, little triangular pyramid. It's missing one piece. Yeah, I can totally make that. Okay. So to make that, take the base of it. Suppose we align this onto the axis again. It might be nice if it wasn't aligned to the axis. Of course, we could apply a transformation to make it not aligned to. That would be perfectly fine. But we've got these 3 points, and we got some kind of start. We'll say the start's like in the center here. And so we got size. So if you go size units out, you can get each of these points. We just go this direction by size. Then we've got this one right there, except we also have to go down by that proportion right there. And so that proportion, these angles here they're inside a triangle, so they're 60. So if this is size from there to there, We just have to define what size is. It doesn't have to be this thing. But if we say that size, then the question is, what is this distance right there? Because that's our other important distance, the small distance. That there is again size, and of course that's size. That one's. If it was size, sorry, I'm confused in my whole triangles thing. I think maybe this. Well, if that's size and that's size, then this is 45 degrees out here. So if that's size and that's size, then that would be a 45-degree angle. But that's fine, because this one's a 60-degree. I think we're good. I think that's actually size. That's my opinion now. I'm not sure it's worth anything. That's what it is. Okay, so we take this and lay it out. Let's say we're going to lay it out with, say, X and Z. Okay. So, for the points, we got points A, B, C, and D here, right? So, the reach of vector 4. Okay. Okay, so, point A, we got to name these things. A, B, C. And then that one out there is D. Okay, so with all these things named like that, A is going to be at our spot, and then what we're going to have to add on to our spot is we'll use a vector 4 here, and so it's got for the X coordinate with A, we got to take it and subtract size. For the Y coordinate, well, it's down from spot. Like if you look at the side view, it's the same kind of thing. It's down size. For the Z coordinate, this way, we're also down by size. What is that consistent now? Okay. Okay. So then these other ones, these are there will probably be some multiple of size. Okay. So the spot B there, we just got to do a sign reversal on something. X. X needs to be plus size. Okay. Then we got C here. That's going to have no adjustment at all on X. Oops, that's the wrong one. And it's going to be size up on Z. And we're again down in the lower plane here. So then when we pop up this top one, the difference here for Y, we're at size. And since the top point is right centered on the origin there, except up a bit on Y, we want to say 0 on each of these. Okay, so now we've got our 4 corners of our little triangle thing. And so we just have to draw them. Okay. So, interesting thing about Init Simple, it doesn't really support a color, and we might like to have a color because the fruit should be a different color. So, let's make a different one. FB init. Okay, this emits fruit vertices. And so it's got a position, and that's all it needs. Okay. So fruit emit here is to say GL position equals pause, and then we need to set our color. So we'll say fruit is red, why not? Sort of depends what kind of fruit we have, I guess. And I don't want to be like green or any kind of green derivative. Like we don't want to grow granny smith apples here because they're going to be hard to see on our tree. It's better if we grow red delicious or something like that. Okay. Init. And that's going to be capital E. Otherwise, it'll tell us that it'll give us a weird error. Okay. So vertices on here. We can always start with that triangle if we want to. That's not how we do it. A, B, C. We could make an array and loop through it or something like that, but this will be okay. Okay, so if we've gone 1, 2, 3, we've drawn the bottom triangle. So we've actually got 3 triangles left to go. I'll go ahead and color these as we go. So we went this way, A, B, C. So this bottom one, we haven't drawn that there, but we didn't ever go from C to A on our vertex list here, but that's drawn. So now if we go up to D, that will draw the triangle off on this side. So this triangle right here will have gotten drawn, and we're up there. We didn't actually go there. We're there. So we still got to do this one over here. And so if we go back to B, it's going to do that because it takes the previous 2. So we went A, B, C. We went up to D. We go back to B. It'll be B, D, and C that define the corners of our new triangle.
And then we have to go back to A.
Yep. Okay. I haven't thought about winding order a whole lot here, but I think that draws the right triangles. Okay, so we can make a fruit. Now we might or might not want to make a fruit. If we have a branch that's not terminal, we don't necessarily want to make a fruit. So it's only really short branches that have a fruit at the end. So I'll say if distance, okay, GL and 0.GL position, and the other one. Okay, say if the distance, so they get a lot shorter as they go. I'm not quite sure what a good value is here. Say greater than 0.1. I think they're actually pretty long, and so I think that's probably quite wrong. But we can adjust that later. Then we want to make a fruit. Okay. Now I happen to know that the vertex order we set up in a tree is that every line comes from the tree, and then the second vertex is the end of that branch. Just because that's how the generation algorithm works. So since that's the case, the GL position at position 1 is the vertex that's at the end of the branch. So that's where we want to start. And in the size, I don't know.
Except that should be PO, not PB.
Yeah. Okay. So that should make the second, should make the fruit there. Okay, in some cases. So then we want to make, oh yeah, we already said locations is 2. Max vertices, we said 8. I guess that's still true. Because we might do 8 if we're doing a branch, or we might do 6 in the other case. So the max vertices is 8. Okay. Goodness gracious. So a couple things are going on here. First of all, the fruit is not the right color. Secondly, it fruits way too often. And thirdly, the fruit is way too big. And fourthly, the fruit is a weird triangular shape.
That's fine.
Okay, so is it F color is that? That's the outback for F color. What if the fragment shader is doing something weird there?
People cut fruit in triangles all the time, might as well grow it like that for them.
Yeah. Let's say 0.03. Okay, I'm not sure what the distance scale is here exactly. Let's take a look at our fragment shader. Okay. So we're obviously doing gerbolator here. And it looks okay. We can take the gravitator out of here, clarify we're using gerbolator, and in comes F color. That looks fine. So that's a weird color. Color equals vector. Oh, that's, oh, what did we say 1 there? Oh, actually, I think that's because of the way the shader works, the fragment shader. I was putting a 1 there because it needs to have a 1 there. But it looks like the shader here actually disassembles the vector, puts a 1 on the end of it, and puts that in its output there. So it's fine. Okay. Let's disable this one for just a moment. Okay, well, if that's true, we'll return. That should actually disable the branches. We should just get the pilot fruit, okay? So the ugly green color, that's still coming from our vertex shader. I think this one might be the, one of those is ugly green color. Let's say we change all of these to blue. Okay. We'll leave some other color complex in there too, so we can see what's going on. Okay, so we're definitely getting the vertex shader colors down here. Oh, I said image simple. Image simple is the branches one up there. We want FB emit. There we go. Better. Okay. Next thing, the fruit is just plain too big. Next thing, let's add the branches back in. There we go. We have a purple tree with triangular prism-shaped red fruit.
Entirely too much triangular prism red fruit.
Yeah, it goes too far into there again, doesn't it? Okay, well, let's fix that then. Okay. So we said we'll make a fruit if it's just a bigger distance than that. Let's make it smaller.
It didn't change.
If the distance there is greater than this, then we make the fruit. How small is it? Part of the problem here is we're applying our transformation matrix too far in advance. Is that 0? For some reason? Okay, we can actually turn off the fruit there if we want to. So if it's greater than, wait a minute, if it's greater than 1, we got exactly one spot on it where we had a fruit. So if we say greater than 0.5, we got fruit on the bottom. Oh, but you see the fruit coming and going?
Uh-huh.
That is because of our transformation happening in the vertex shader. And so we are working with the post vertex shader distances. And it doesn't throw us off into branches at all, because on the branches, we've already figured all that stuff out. You know, the branches tell us they're scaled appropriately regardless of what we do there. Okay, so if we were to say the opposite of this, less than 0.5, you can see there's fruits sometimes too far, sometimes they disappear, sometimes they float in the air over the tree for reasons I'm not quite sure of. So if we say less than 0.3, I should restrict it further. There we go. Now it's not fruiting from the base. It's just that your fruit, just got to be quick, you know, you see it, you eat it. It's like a real tree. It grows fruit and sometimes the fruit disappears.
I still want to know why there's not one that's just floating up in the sky.
Yeah, that was a lot.
So would a good use for the geometry shader be adding fur to something?
That was one of the original ideas for using it, yeah. I think that's more something people are doing the tessellation shader. But if you look online for a geometry shader using fur, you know, you get stuff about it, because from OpenGL 3 until 4, that was what they were for. The geometry shader has lost some of its uses. Since the tessellation shaders came in, basically.
So what do the tessellation shaders do differently?
They have a fixed step in the middle where you have a tessellation control one and a tessellation evaluation one with this little fixed piece in the middle. It basically does the level of detail stuff in a more hybrid kind of fixed and programmable way, I guess, since it has a fixed phase in the middle. So it runs a little bit faster. Okay, so the geometry shader is here. So we did that. Okay, so now dropping the fruit. So it'd be cool to be able to drop the fruit. That happens eventually. It falls off and lands. So all we have to know is how far down it ought to be at any given point. Now let's go ahead and move our MVP calculation here too, just to make everything kind of straightened out in a way. And let's see, uniform. at 4 MVP. Okay, if we just change it in our functions here, then it'll get applied automatically in the geometry shader. Okay, it has to come out of the vertex shader because we can't apply it twice. That would be very bad if we did. Okay, shouldn't have changed very much. Our fruit seems to be maybe healthier. I'm not sure why the one fruit there is disappearing, but by and large, the fruit appears far more static than it did a moment ago.
There was actually 2 fruits that were disappearing.
Yeah. So we got MVP is applied later. That's good. So then down here, I think 0.3 is a bit much, maybe like 0.1. And I think that fruit size is a little much too. There we go. Okay, better. So I got the one on top. Okay, so fruit falling, making a fruit fall. So if the fruit falls, then we just have to change its GL position so that it is lower down. That means we have to pass in something for the fruit height. So we can do that. We'll say uniform float, and so I'll just call it a fruit drop. And this will be a parameter related to how far the fruit is supposed to have dropped. Okay, so then we have to add that in our program and decide how we're going to control it. So you can add more of these things here. We had the wind there before. So we just make a second one for fruit drop. And call this uniform drop. Okay. There we go. Uniform MVP. You know, that's actually quite wrong up there too. Okay. So there we go. And then these things all have entries up here. Okay. So we have to decide what it actually is. So down here we calculated the wind and added right there. So if we say GL uniform 1F, uniform fruit drop, then we just have to give it a parameter related to this. So we can take the time and come up with some kind of calculation based on it. Now, if we put the calculation in the geometry shader, then it's going to slow up all the invocation ID zeros in a geometry shader doing this calculation. So that we have the opportunity to do the calculation for a fruit height just once on the CPU if it's going to be uniform between all of them. So we'll convert this all the way down to a fall distance. So fall distance. We can calculate that. We'll start out with 0, and we'll take the time. So I'll say, I think it returns an int. That's the time in milliseconds. Okay. So if time is less than 1,000, we'll just go ahead and leave it. So if time is greater than 1,000, we'll say the fruit is falling. Okay, so we can say fall distance equals time minus 1,000 to indicate the initial 1 second before it starts falling. And then we want to divide it by something, since these units are pretty small. It has to go into like a 2 or something. 0. Okay, so we take the time divided minus 1,000, and convert this to a float, and then divide it by, say, so if we do it 1,000, it'll be 1 OpenGL unit per second. That might be a little on the fast side. Maybe do like 3,000. Okay, and then if the fall distance is the point where it's at the ground, we might have to just stop it on the ground in the geometry shader. The reason is the fruit is starting out at all different heights. And so if we calculate when it ought to stop by hitting the ground on the CPU, we don't know this on a per fruit basis. We just know it generally. So the geometry shader has to take care of the per fruit calculation here. And that's kind of natural. Okay. So back to the geometry shader. We got this position here, but we might want to take it and change it by using the fruit drop. And so we'd say position And we want to just to modify the y coordinate, but if we say something like plus vec4 0 minus root drop 0 0. Okay, so that'll just adjust the y coordinate by dropping it by however much it needs to. We could modify our MVP matrix, I suppose, but it's uniform, so we can't actually modify it. We could modify a copy if we wanted. Okay, so there's our fruit drop. Now, if the fruit hits the ground, we want it to stop falling, but let's see what happens so far. After a second, the fruit drops. And it continues on down. It's also affected by the wind after it drops. Maybe it shouldn't be.
It also phases through the ground.
Yeah, it does. I think it should fall a little bit faster too. I think that 3,000 was excessive. Okay. So if we want to take out the wind is applied. Actually, the wind is applied in the vertex shader. We have to move the wind calculations over here. Let's go ahead and stop it first. And so we want to do negative fruit drop, but we want to use kind of a maximum, or well, let's say minimum, of the negative fruit drop and the distance to the ground. Negative pause dot y. Okay. So if the distance to the ground is, this is not the way we want it to be solved. I'm going to take the minus signs out. So I'm going to drop it the minimum of what the fruit drop is, or the distance that it says is the distance to the ground. Well, I think the ground might actually be at -2. We might have to do a little bit more arithmetic here. I might stop too early. Okay. That's not good. Whatever happened there. Oh, it's working. Okay. So the y position, I think the tree actually starts at like -2. If we look at the cube here, we can see where it starts. It starts at -2, right there. Shrub maker takes as a parameter the x, y, and z location of the start of the tree. So we want this plus 2, because it can drop 2 would be okay there. Okay, there's the fruit. There it goes. See it all land on the ground? Cool. Except that it's still being blown around the wind.
Looks less like fruit and more like leaves.
Yeah.
Let's make it green, and it is leaves.
Oh, that's true. We could just make it be green. But I wrote fruit in the program a whole bunch of times.
Switch room, please.
Yeah, do that. Okay. So I kind of like how that works, using the geometry shader there to draw fruit in appropriate places for our tree with non-infinitely thin branches. Okay. Let's try making the tree bigger. Let's see, we got 6 there. I'm not sure how well this actually is going to hold up to a bigger tree. I think it might look silly for some reason.
Actually, it's not. Now it really does look like leaves.
Yeah, it does. So it turns blue at some point.
Oh.
That's in the vertex shader. So the vertex shader, basically we don't have very much for the vertex shader to do, and as few functions are slowly being taken away from it. Like we kind of like to apply the wind actually just to the branches and not the falling fruit. At least not if it's falling. And so, yeah, we just get rid of the whole thing. So the displacement here on the wind, I think the wind looks kind of okay. Okay, so here's the blue thing on the top. So we made our tree blue and purple, which is really not very good. Let's just grab this whole thing up here, and here's how I'll do it. I'm going to put that into this file. Okay. So if we want to move the wind is happening as an adjustment right there. before we actually apply our matrix to it. So if we put this up here instead, we kind of are going to need these calculations unless we have fruit and we are dropping. Otherwise, we're fine. So we take that and put it right up here, and the thing happens regardless of invocation ID. Now, it's a little bit unfortunate, but this ends up being calculated a fair number of times. Okay, now this chord 3D is the original coordinate for the vertex shader. We don't have a chord 3D in here anywhere. So the X disp and the Z disp and the chord 3D, this is probably actually the issue to take care of perhaps on an every vertex sort of basis. But we can go ahead and change the input ones. I don't know if we're allowed to change GLN. We can find out. Okay, so we take this thing, we want to take the Y, or the, no, we want to take the X and plus equal on this thing right here. That would be GL n0.gl position dot y plus 2 divided by 5.0 times the wind. Okay, so I think that is that formula there. X disp and Z disp are used later. Okay, so that changes the X position for position 0, and you know this is for 1. Now, I'm sort of expecting to get told here that we're not allowed to do this because we're trying to change this GLN thing, which is in common between our two invocations. Let's see what happens. Okay, this is other stuff from the geometry shader that also has to get removed from there. Okay, so tell us we can't. Tells us we can't. Unexpected. That. It may just be telling us that it can't have this as an L value. So unexpected that, expecting colon, colon. I don't expect that if we were to take this and replace it with colon, colon, then everything would start to work. Not for a moment. I think what's happening here is it doesn't like us changing our GLN. So we can take this and copy it up to something. Back for start equals GLN 0.
Do you need semicolons?
What's that?
Do you need semicolons at the end?
Oh, let's try that. Okay. Well, now we got an assignment. The varying GLN is not allowed. Okay. Okay, so there's start, the end. Okay, so then down here, we just have to change all these references to start or end. Okay, so then down here, again, they got to be changed. Start. It's actually kind of simple. Kind of a lot of these things. Okay, I think that's the only place this is perfect. Okay, undefined variable wind. That's a uniform float. Okay, runs, but everything's of course quite wrong. Okay, so now we need to not apply wind here. This is just going to be chord 3D. You can actually say this. Okay, Then the colors, we've still got our weird colors. Let's switch to a little more tree-like colors. So if our position is great enough, then we want to be green. So RGB, minimize the blue. If it's lower, we want to be brown. So put some red in, and some of this, and less blue. Okay.
The
Does it
tree is
fall?
still wonky, but everything falls, and once it, no, it's still being affected by wind.
Yeah, the wind is still definitely affecting us.
But the wind is doing differently. The wind is instead making the whole scene shift instead of making.
I think if the wind was doing that, I'd be concerned.
Yeah, that's the powerful
I'm
wind.
gonna die.
Yeah.
Yeah. Okay, so we got the wind affecting these things, kind of maybe more than it should. The start dot y, this looks like the same wind algorithm we had. But let's see what happens when we drop the wind off of the fruit. So we'll only have this if GL invocation ID is 1, or excuse me, 0, or the fruit drop is equal to 0. And we apply the wind. Otherwise, we don't apply the wind.
Now, if only we could get the tree to stand up to the position it's supposed to be in.
Yeah, if the tree would be upright again, that would be really cool. Okay, so I'm not sure what's wrong with the little formula over here. Let's pull the other one in on the side. So the other one, what we started with, is this one. And so before we said if the y-coordinate is greater than -2, then we'll apply the wind. Otherwise, we won't. Well, that's quite different, isn't it? We didn't say that before. Okay, and that's kind of on a case-by-case basis here. The reason is here in the geometry shader, we're dealing with both ends of the line. Over here, we're only dealing with one vertex at a time in the vertex shader. So the vertex shader is applying this on a per vertex basis. So to do that, we have to pass this in certain cases. So if it's greater than -2, then we adjust this. So the converse to that is if start dot y is less than -2, then we want to skip it. Oh, actually greater than -2 is fine here. Okay, and we do that. Same thing for the end. Okay, so that should be similar. And it's all changed before we ever do the thing there with the GL position. Yeah, let's see what happens. Okay, make that one disappear. The tree is a little bit wonky now.
That's a bit of an understatement.
Looks like our tree a little smaller. This will affect things because of it's shorter. I think we were running this on 10 the whole time before. But that's not really it. The issue is that it's very crooked.
I also love how only the bottom vertex is the only part that's not moving.
Right. Well,
It's just it's stuck in the ground, and the rest of the tree is as a whole just going.
right.
Put some sunglasses on that tree, and it'll look like it's dancing.
Let's try 0 on here. I'm curious of leaving it unaffected for longer. Okay. Cool, except that.
That's great.
Okay, so there's clearly something quite wrong about the way this is applied to this. So I'm not sure what's different on the formulas, really. I mean, it looks like kind of the same. Oh, there's a parenthesis somewhere. Hey, that's it. Parentheses. parentheses make a big difference here.
Sort of.
They make a difference.
They do make a difference. The tree now stands up.
So, well, if we put these back in -2, where they've been. There we go.
Oh, hey, that looks pretty much exactly like it used to. There we go.
Okay, finally back. Well, that was kind of commute entry. Rusty, I'm supposed to be out of time. Sorry, still got this silly cold. Hoping it's gone by next week when we have this class again. I'm hoping Nina doesn't get it because I've been sick of using this computer. I should probably clean the keyboard or burn it or something. Okay.
You can just dump hand sanitizer all over it.
I probably actually should. So there's so this level. Okay, so we did that. Okay. So back to the role of danger in slowing everything down by application of a geometry shader in making a long serialized single-threaded kind of process. That's sort of what we did here. Like, this thing's pretty cool, right? It makes a tree. The tree waves around in the breeze. The tree drops fruit. We try to minimize the impact of having a long single-threaded geometry shader process by using multiple invocations, so that at least the fruit is drawn in one invocation and the rest of the tree is drawn in a different invocation. And that was good. That doubled the number of invocations, so we can use more of the shaders on the card. But the number of vertices per shader is either 8 or 6, depending on what we're doing. And we've got quite a lot of calculations that are done on a per primitive basis here. And it's not just per primitive. I mean, we're outputting like 4 primitives, or is it 4? Yeah, it's 4 both ways, actually. Either way we go, we're outputting 4 primitives from one thread. And so we've kind of interfered a little bit with the massively multi-threaded, lots of little tiny operations nature of the GPU. Yeah, I know, basically. So I think tessellation shaders will be next time. And this is kind of a fun geometry shader example. It's like, well, you can do just about everything in a geometry shader, can't you? And yeah, you can. You can do a lot of stuff in a geometry shader. You can make a very fancy program in a geometry shader if you want to. A very fancy, like, single-threaded one. We can put the whole tree in a single invocation. What we do is we pass a point to the geometry shader, and that's where it starts. And then it generates the whole tree and the fruit and drops it all off and everything. You see, we could totally just use one of those 1,920 shaders here.
So each invocation is different core, right?
It can be put on a different one, yes.
Okay. So if you were to make fur, you want 10,000 invocations.
Yeah. And so that's one trick to using these things and not totally disrupting the multi-threaded nature. Use lots of invocations from the same one. So if you wanted to draw like a koosh ball, do you still sell koosh balls?
Somewhere. Somewhere.
Okay. Well, when I was growing up, we had these things we throw at each other called a koosh ball. And it had like a rubber core, and it had all these little frondy things hanging off it. And so they're actually kind of cool. But if you caught it by a frondy thing, the frondy thing would tend to break. So you try to catch it and just kind of like grab the whole thing. Anyway, you're drawing a koosh ball, and you're passing a point to your geometry shader. And a geometry shader is going to make the whole rest of a koosh ball. You want to have like one invocation per strand of rubber or something like that, so that you don't bog it down. Not one invocation per koosh ball, you see? Okay, so that's the big warning with geometry shaders that we really kind of pushed today. So keep that in mind, and we'll come back to tessellation shaders. I'll do feedback in the near future. I haven't found like a super simple example of feedback in a tutorial, and I have been looking. So I think you're going to have a me tutorial from that one, which is probably going to be really weird, because usually things I write are really weird. The compute shaders, we'll get there a little bit later. They're fun. We'll get there. Okay. So that's that. Remember to think about the project if you have any particular suggestions. Otherwise, I'll come up with some kind of constraints that basically try to articulate, make a complicated enough project that you learn how to program a GPU. But I'll say that in however many words it sounds like I need to, which will probably be a whole bunch of them. But when you see the project description, if you're like, man, I can't be bothered to read that, that's what it's going to mean. So that's that. Okay.
Just make the project
Yeah, yeah.
Oh, Lord, no.
Make a project that utilizes at least 40% of the following features, and then just like append a, PDF of the specification.
Yeah, that sounds horrible.